Hello and welcome everyone. I am here to discuss on noise pollution. This module is under the paper Environmental Health in the subject of Social Medicine and Community Health. This module has been developed by a team and the team members are myself, Dr. Madhutandra Sarkar as content writer, Dr. V.M. Gupta as paper coordinator and Dr. C.P. Mishra as principal investigator as well as content reviewer. This module has been developed with the intention that after completing this module, the students will be able to define the terms noise and noise pollution, understand the properties and measurement of sound or noise, describe the sources of noise pollution, understand the effects of noise exposure, and last but not the least, describe prevention and control of noise pollution. Sound is a form of energy. Sound is made when air molecules vibrate and move in a pattern called sound waves. Sound waves travel to the ears and then to the brain, and we can recognize that sound. The frequency limits of audibility for humans range from 20 to 20,000 Hz. A healthy human ear responds to a very wide range of sound pressure level from the threshold of hearing at 0 decibel, uncomfortable at 100 to 120 decibel, to painful at 130 to 140 decibel. The persistent and escalating sources of sound can often be considered an annoyance for many people. The word noise comes from the Latin word nauseous, meaning seasickness. Noise is defined as unwanted or disturbing sound. Sound becomes unwanted when it either interferes with normal activities such as sleeping, conversation, or disrupts or diminishes one's quality of life. Generally, noise is produced by household gadgets, be it trucks, vehicles, and motorcycles on the road, jet planes and helicopters hovering over cities, loudspeakers, etc. Transportation noise is among the most pervasive noise sources in the environment today. Sound or noise is measured in the units of decibels and is denoted by the dB. Noise is considered as environmental pollution. Noise can cause a number of short and long-term health problems. The noise-related problems include stress-related illnesses, high blood pressure, speech interference, hearing loss, sleep disruption, and loss of productivity. However, noise-induced hearing loss is the most common and widely discussed health effect. NIHL or noise-induced hearing loss has global implications, with 10 million adults and 5.2 million children in the US and 250 million people worldwide having a noise-induced hearing loss, that is loss greater than 25 decibel, a clinically significant hearing loss. Moreover, worldwide 16% of the disabling hearing loss in adults, that is over 4 million disability adjusted life years, is attributed to occupational noise ranging from 7% to 21% in the various sub-regions. Noise not only has adverse effects on humans, noise pollution has negative effects on a range of animals across a variety of habitats, for example birds, land animals, and marine animals. Noise should be strictly controlled to reduce its impact on humans, animals, and ecosystems. Despite the seriousness of this problem, noise is often an underestimated threat as it is thought to have less damage on humans than water or air pollution. What is noise pollution? How to define it? The traditional definition of noise is unwanted or disturbing sound. Section 2A of the Air Prevention and Control of Pollution Act 1981 includes noise in the definition of air pollutant. Noise pollution can be defined as unwanted or offensive sounds that unreasonably intrude into our daily activities. Noise pollution is almost entirely human-generated. Noise pollution takes place when there is either excessive amount of noise or an unpleasant sound that causes temporary disruption in the natural balance. What are the properties of sound or noise? First property is wavelength. The wavelength is the distance travelled by a sound wave during one sound pressure cycle. This is usually measured in meters or feet. The following picture shows a wavelength. Next is speed. This is typically measured in meters per second or feet per second. Next is frequency. Frequency is defined as the number of compressions and decompressions or rarefactions per unit time, that is second. Unit of frequency is hertz and 1 hertz is equal to 1 cycle per second. The speed of sound, the frequency and the wavelength are related by the equation wavelength equals to speed of sound by frequency. Next is sound pressure. It is used as the fundamental measure of sound amplitude. It is convenient to employ sound pressure level, a quantity which is proportional to the logarithm of sound pressure. The sound pressure level is expressed in the unit of decibel. This figure depicts sound level and corresponding sound pressure of common sound sources. 0 decibel is designated as threshold of hearing. At 60 decibel, conversational speech is possible. 2 represents sound level and corresponding sound pressure of common sound sources. Threshold of hearing is placed at 0 decibel. Conversational speech is possible at 60 decibel. Pop group at 110 decibel. And threshold of pain is placed at 140 decibel. Equivalent continuous sound pressure level is the level of that steady sound which over the same interval of time contains the same total energy or dose as the fluctuating sound. Equivalent continuous sound pressure level has gained widespread acceptance as a scale for the measurement of long-term noise exposure. It can be obtained from variable sound pressure level over a time period. Following is the formula for calculation of equivalent continuous sound pressure level. Next, loudness and frequency weighing networks. The magnitude of a sound as perceived by human ear is called its loudness. Ear is not equally sensitive at all frequencies and amplitude of sound pressure. To obtain levels which bear a closer relationship to loudness judgments than sound pressure levels, so-called frequency weighting networks are incorporated in sound level meters. Such levels are termed as sound levels. Generally, 3 types of filters having frequency response curves A, B and C are employed to match the ear response at low, medium and high loudness respectively. However, extensive experience has shown that a filter usually provides the highest correlation between physical measurements and subjective evaluations of loudness of noise. Levels on the A scale are commonly expressed in decibel A. Figure 3 depicts frequency weighing networks for sound level meter. Here you can see there are three curves A, B and C. And A is the lowest curve, B is placed at the medium level and C at the highest level. This figure depicts functional schematic diagram of a sound level meter. You can see that microphone of sound level meter transforming sound signal into electrical signal. When sound waves are hitting microphone, a diaphragm is vibrating and it converts the signal into electronic signal. And electronic network then modifies signal to give meaningful results and which is displaying in the visual display and communicates results to person. Next is noise dosimeter. A noise dosimeter is like a sound level meter except that it stores sound level measurements and integrates these measurements over time, providing an average noise exposure reading for a given period of time, such as an 8-hour workday. With a dosimeter, a microphone is attached to the worker's clothing. Dosimeters can function as personal or area noise monitors. These are also used to collect data for use in legal proceedings, development of engineering noise controls, and other industrial hygiene purposes. Noise pollution, like other types of environmental pollution, is also the result of industrialization, urbanization, and modern civilization. Noise from transportation is by far the most widespread source of noise exposure, causing most annoyance and public health concern. Broadly, noise pollution has two sources, that is industrial and non-industrial. Industrial and occupational source. Industrial source includes the noise originated from various industries, mills, and big machines working at a very high speed and high noise intensity. Noise from mechanical saws and pneumatic drills is unbearable and a nuisance to the public. Industrial workers who are exposed to noise for 8 hours per day and 6 days per week are victims of occupational noise pollution. Next is non-industrial source of noise pollution. Non-industrial sources of noise include the noise originated from transport or vehicular traffic and the neighborhood noise from variety of sources. Transportation noise mainly consists of traffic noise from road, rail, and aircraft. Noise levels are particularly acute near railway junctions, traffic roundabouts, bus terminuses, and airports. Of the transportation noise, vehicular noise is the one that affects the urban population the most. These consist of engine and exhaust noise, indiscriminate use of horns, use of pressure horns, and auto repair workshop. In addition, noise from the interaction of tires with the roadway is generated by trucks, buses, etc. Trains, overground and underground, and aeroplanes flying over houses close to busy airports are other sources of noise pollution. Noise from railways and aircrafts are of major concern in big cities. The noise from locomotive engines, horns and whistles, and switching and shunting operations in rail yards can impact neighboring communities and railroad workers. Railway noise is causing increasing concern due to high-speed trains and increasing freight train traffic during the night. Nowadays, the problem of military aircrafts flying at supersonic speed has added a new dimension to noise pollution. Next, neighborhood noise. This type of noise includes disturbance from household gadgets and community. Common sources include musical instruments, TV, VCR, radios, transistors, telephones, music in public functions and loudspeakers, etc. It also includes noise from household gadgets, for example, washing machines, vacuum cleaners, some kitchen appliances, etc. Apartment dwellers are often annoyed by noise in their homes, especially when the building is not well designed and constructed. The noise from the construction of highways, city streets, and buildings is a major contributor to the urban noise. Construction noise sources include pneumatic hammers, air compressors, bulldozers, loaders, dump trucks, and pavement breakers. Bursting of firecrackers is a health hazard as it causes both noise pollution as well as air pollution. Next, effects of noise exposure. Noise exposure has effects on humans. The health effects of noise are considered as an emerging environmental burden of disease issue by the World Health Organization and the European Environmental Agency. Effects of noise can be divided into two types, that is, auditory and non-auditory effects. This figure depicts WHO pyramid of health effects of noise. It shows that at the base level, that is when severity of the noise is lower, feeling of discomfort starts, that is disturbance, annoyance and sleep disturbance. Then as severity increases, the stress hormones get released, followed by increase of blood pressure, cholesterol and glucose, which are the risk factors for cardiovascular diseases. So as severity increases further, cardiovascular disease or insomnia develops, and at the top of the pyramid it shows mortality. Means when the severity is maximum, it can cause even mortality. This figure depicts effects of noise pollution. You can see that effects of noise pollution can be grouped into auditory effects and non-auditory effects. Auditory effects are auditory fatigue and deafness, and non-auditory effects are annoyance, loss of working efficiency, interference in speech communication, and physical disorder like increase in heart beats, blood pressure, etc. Auditory effects include noise-induced hearing loss. It is a public health problem. According to WHO, 10% of the world population is exposed to sound pressure levels that could potentially cause noise-induced hearing loss. In about half of them, auditory damage can be attributed to exposure to intense noise. Tinnitus, that is, change in sound perception, such as ringing, that cannot be attributed to an external source, often follows acute and chronic noise exposure and persists in a high proportion of affected individuals for extended periods. Tinnitus can affect quality of life in several ways, including through sleep disturbance, depression, or the inability to sustain attention. The fact that hearing loss and tinnitus are reported in combination suggests that both symptoms share common pathophysiological pathways. Noise-induced hearing loss can be caused by a one-time exposure to an intense impulse sound such as gunfire, or by steady-state prolonged exposure with sound pressure levels above 75 to 85 decibel, for example in industrial settings. Noise is the major preventable cause of hearing loss. The characteristic pathological feature of noise-induced hearing loss is the loss of auditory sensory cells in the cochlea. At first, Hearing loss is usually temporary and recovery takes place over a few days. After further exposure, people may not fully recover and develop deafness. Prevention of noise-induced hearing loss is the only option to preserve hearing. Next, non-auditory health effects. Non-auditory health effects include annoyance. Annoyance is the most prevalent community response in a population exposed to environmental noise. Even relatively low levels of noise can cause annoyance and frustration. Natural sounds are generally less annoying than unnecessary or controllable sound such as car horns. Next, speech interference. Noise can interfere with speech. When the background noise level is 50 decibel, normal conversation can be easily carried out with someone up to 1 meter away. The problems will arise after that level. Next is sleep disturbance. It is thought to be the most deleterious non-auditory effect of environmental noise exposure because undisturbed sleep of a sufficient length is needed for daytime alertness and performance, quality of life, and health. Elderly people, children, shift workers, and people with a pre-existing sleep disorder are thought of as at-risk groups for noise-induced sleep disturbance. External noise measuring up to 30 decibel A in a bedroom is appropriate for sleep. Next non-auditory effect is decreased work performance. Noise pollution can make people nervous. Accordingly, it can prevent people from concentrating on their work. As noise levels increase, ability to concentrate and work efficiently and accurately reduces. Next non-auditory effect is cardiovascular effects. The cardiovascular effects of noise have been the source of growing interest in recent years. Investigators have repeatedly noted that noise exposure increases systolic and diastolic blood pressure, changes in heart rate, and causes the release of stress hormones including catecholamines and glucocorticoids. The general stress model is the rationale behind these reactions. Moreover, sleep is an important modulator of cardiovascular function. Non-disturbed sleep in this respect must be considered as a particular potential pathway for the development of cardiovascular disorders. Chronic exposure can cause an imbalance in an organism's homeostasis, that is allostatic load, which affects metabolism and the cardiovascular system, with increases in established cardiovascular disease risk factors such as blood pressure, blood lipid concentrations, blood viscosity, and blood glucose concentrations. These changes increase the risk of hypertension, arteriosclerosis, and are related to severe events such as myocardial infarction and stroke. Next is cognitive impairment. Postulated mechanisms for noise effects on children's cognition include communication difficulties, impaired attention, increased arousal, learned helplessness, frustration, noise annoyance, and consequences of sleep disturbance on performance. Investigators have also suggested psychological stress responses as a mechanism because children are poor at appraising threats from stressors and have less well-developed coping strategies than do adults. Several studies have shown that environmental noise exposure has a negative effect on children's learning outcomes and cognitive performance. WHO community noise guidelines suggest that the background sound pressure level should not exceed 35 decibel during teaching sessions. Several studies suggest that noise reduction can eliminate noise effects on cognition. This table shows WHO guideline values for community noise. Like outdoor living areas should have 50 to 55 decibel of sound level. In indoor dwellings, it should be 35 decibel. In bedrooms, it should be 30 decibel. In school classrooms, it should be 35 decibel. Industrial, commercial and traffic areas, it should be 70 decibel. Music through earphones. To listen music through earphones, it should be 85 decibel. And ceremonies and entertainment, in the areas of ceremonies and entertainment places, it should be 100 decibel. Next, not only noise pollution has effects on humans. Effects of noise on animals, plants and ecosystems are: changes to noise levels have important consequences for ecosystems and the species that inhabit them. Anthropogenic noise pollution, that is in cities, roads, ships and machines, is affecting a range of animals across multiple habitats. Animals are altering their natural behaviors or relocating to avoid noisy areas because of noise pollution. Noise also can have detrimental effect on animals by interfering the use of the sounds in communication, especially in relation to reproduction and in navigation. Changes in animal behavior can have flow-on effects for whole ecosystems. Not only land animals, marine animals are also affected by noise from a range of human activities, including commercial vessel traffic, oil and gas exploration, seismic surveys, military sonar and others. Moreover, the population and diversity of certain bird populations has been shown to decline or change when exposed to continuous noise generated by urban environments. Because many animals also pollinate plants or eat or disperse their seeds, human noise can have ripple effects on plants too. Effects of noise on building and materials. Vibrations induced by sound waves can cause structural damage to the buildings and materials. These may even get collapsed by exposure to infrasonic or ultrasonic waves. Lastly, prevention and control of noise pollution. First, noise control techniques. An effective approach to noise control usually consists of the following three steps: control of noise at the source, control along the transmission path, and control at the receiver. This figure depicts different noise management strategies like noise reduction at source, interruption along transmission path, isolation of the person, personal ear protection, noise attenuating diffuse, job rotation. This figure depicts noise control procedures applied to source, path and receiver. Possible noise control procedures for source are modify, redesign and relocate. Possible noise control procedures for path are enclosure, absorption and barrier. And possible noise control procedures for receiver are enclosure, absorption and relocate. Next, control of noise at the source. Reduction of the noise levels from domestic sectors, maintenance of cars, control over vibrations using proper foundations, rubber padding, etc., low voice speaking, prohibition on usage of loudspeakers, optimal selection of machinery, maintenance of machines, and installation of silencers. These are the effective measures to control of noise at the source. Control along the transmission path. The measures include installation of barriers between noise source and receiver, design of building, use of suitable noise absorbing material will be helpful, installation of sound insulating panels or enclosures, green belt development, acoustic zoning, that is zoning of noisy areas away from residential areas. This figure depicts attenuation of noise levels using barriers. Here you can see In one figure, barriers has been placed close to source, and in another, barriers has been placed close to receiver. Next is control at the receiver. The measures are protection of the receiver by altering the work schedule or job rotation, provision of personal protection devices such as earplugs, earmuffs, noise helmets, headphones, etc. More importantly, education of the persons who are exposed to potentially hazardous noise level regarding the possible consequences of excessive noise exposure, the means of protection, and the limitations of these means. For example, improper use of earmuffs. Next is preventive measures. These are prescribed noise limits for vehicular traffic, ban honking, usage of horns in certain areas, create silent zones near schools and hospitals, redesign buildings to make them noise-proof, reduce traffic density in residential areas, give preference to mass public transport system, use loudspeakers and amplifiers at minimum, especially near silent zones, ban pressure horns in automobiles, emphasize environmental impact assessment and green design at the stage of urban planning. Frame a separate Noise Pollution Act. Next, the Noise Pollution Regulation and Control Rules 2000. For better regulation of noise pollution, there are the Noise Pollution Regulation and Control Rules 2000 under the Environment Protection Act 1986. Whereas the increasing ambient noise levels in public places from various sources inter alia, industrial activity, construction activity, generator sets, loudspeakers, public address dumps, music systems, vehicular horns, and other mechanical devices have mysterious effects on human health and the psychological well-being of the people, it is considered necessary to regulate and control noise-producing and venerating sources with the objective of maintaining the ambient air quality standards in respect of noise. This table shows ambient air quality standards in respect of noise. In industrial area, limits in daytime should be 75 decibel and at night time 70 decibel. In commercial area, in daytime, the limit should be 65 decibel and at night time it should be 55 decibel. In residential area, the limit should be 55 decibel at daytime and 45 decibel at night time. And in the silence zone, it should be 50 decibel at daytime and 40 decibel at night time. Daytime means from 6 am in the morning to 10 pm at night, and night time means from 10 pm at night to 6 am in the morning. And silent zone means it is an area comprising not less than 100 meters around hospitals, educational institutes, courts, religious places, or any other area which is declared as such by the competent authority. Central Pollution Control Board established the National Ambient Noise Monitoring Network covering 70 locations in 7 metro cities, that is 10 in each city, and the cities are Delhi, Lucknow, Hyderabad, Kolkata, Mumbai, Chennai and Bangalore. And these cities are spread over 7 states for continuous monitoring of noise quality in the country. So to summarize, noise pollution defined as unwanted or excessive sound is an undesirable byproduct of modern day life. This is a significant environmental problem in many rapidly urbanizing areas. Broadly, noise pollution has two sources, that is industrial and non-industrial. Non-industrial sources of noise include the noise originated from transport or vehicular traffic and the neighborhood noise from variety of sources. Noise can have a negative effect on humans, domestic and wild animals, plants, ecological systems, buildings, and other structures. Noise has damaging physical, physiological, and psychological effects on humans. A high noise level can even cause permanent hearing impairment. In comparison to other pollutants, the control of environmental noise has been hampered by insufficient knowledge of its effects on humans and lack of defined criteria. Noise can be controlled at the source, along the transmission path, and at the receiver. Protective equipment usage to reduce the noise levels at the receiver is the ultimate step in noise control technology. Moreover, the persons who are exposed to potentially hazardous noise levels should be educated in the possible consequences of excessive noise exposure, the means of protection, and the limitations of these means. Thanks for visiting EPG Pathology and listening to this module.